In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe.
In space, threats can come from any direction. Meteors from deep space. Invisible but deadly bursts of radiation from the sun. Otherworldly landslides from above. And Marsquakes from below.
Outer space is the last place you want to be as a human being.
What makes fire more deadly in orbit than on Earth? What happens to someone exposed to the harsh extremes of outer space?
The saliva, the blood, it goes from a liquid state to a gaseous state.
Buckle up and prepare for space disasters. The year is 2030. A crew of astronauts simply hits the up button in a space elevator. The elevator will bring them to their spacecraft, which will meet them in orbit. They're grateful they don't have to risk the controlled explosion of a rocket launch.
We can now create carbon nanotube fibers that are stronger than steel. And believe it or not, they are strong enough to keep a space elevator afloat in space, so that you can literally climb your way into the heavens.
The 60,000-mile cable is attached to the docking station that revolves at the same rate as the Earth. Just like a geosynchronous satellite, it stays over a fixed spot on the ground. A space elevator would be any astronaut's dream. But the space elevator dream can also turn into a nightmare.
The space elevator has to be anchored to the Earth. But what happens if you have storms and all of a sudden the moorings begin to snap?
With the cable still attached up in space, it will start swinging wildly, striking objects hundreds of miles away in any direction. It's also possible that some type of guidance computer or thruster problem could knock the platform in space off course, snapping the cable at the top. If it happened while a crew is going up or down the cable, they would be in for the last ride of their lives. And the 60,000 miles of cable hurtling toward Earth is long enough to wrap itself around the planet almost 3 times at the equator, creating havoc over a wide area.
It would be not only disastrous and dangerous for the people involved, the kinetic energy of something like that whipping through the atmosphere would be a menace to navigation. So it's going to have an inherent danger in it that any human system has.
This is just one of many potential disasters facing future space explorers. Living in space will also involve grave dangers. Colonies on the Moon or Mars will be faced with threats from all directions, especially above, where sudden spikes of radiation can turn deadly.
If we were walking around on the surface of the moon, I would say our #1 concern should be solar flare. The sun erupts. The protons coming from that flare could kill an astronaut. There have been several flares over the last couple decades, which if we had had astronauts on the moon just walking around in a spacesuit would have been lethal for them.
On Earth, we're protected from most radiation. Earth's atmosphere and magnetic field are like a protective fence, letting only a fraction of particles through. On the Moon and Mars, you are directly in the firing line. The Moon has no atmosphere or magnetic field. Mars has very little atmosphere and only weak localized magnetic fields. NASA takes the solar flare threat seriously because it has already come close to killing Apollo astronauts.
The Apollo lunar landing crews were quite fortunate. In 1972, in August, there was a major solar flare. There was what they call the Great Solar Storm that happened to just take place in between the Apollo 16 mission in April and the Apollo 17 mission in December of that year. Had that occurred while there was a crew on the surface of the moon, they would have been dead.
The effects would be similar to certain people who died in Hiroshima and Nagasaki, those who were not killed in the initial blast, but were overwhelmed by the extreme radiation dosage within several seconds. An astronaut caught in that situation will have little time to react. A flood of deadly particles penetrates the body, killing all of the astronaut's cells in a few brief moments. So it's no surprise that space colonists will need to be constantly on alert.
We're going to need weather reports, but they're going to be space weather reports. We're going to need satellites monitoring the sun, giving us advance warning of flares. The light from the sun takes only 8 minutes to reach the moon. Coming behind it would be the particles, the lethal radiation. You'd have minutes, half an hour, that sort of time frame before you wanted to really be in a shelter. Such a storm might last for a couple days.
One option for protection is living underground. But don't let the barren terrain fool you. The Moon and Mars are still active bodies where natural disasters like those seen on Earth can strike.
I'm here in the Mojave Desert in a cave created by a lava flow underneath 5 or 6 feet of rocks. Well, being underground in a cave may be an option for habitation on the Moon or on Mars. On the surface of the Moon or Mars, there's radiation from the sun, there's cosmic radiation. On Mars, there's dust storms. If we're underground, well, we're safe from those hazards, but we have other hazards. Imagine being in this cave when there's quakes, rocks falling down, crushing us, pinning us.
A Moon or Mars quake could also threaten an above-ground colony. The Moon and Mars don't have tectonic plates like the ones that cause most of Earth's quakes and volcanic eruptions, and there are no signs of active volcanoes. But the Moon and Mars do have hot cores. So as the pressure from that heat heads to the surface, the shaking starts. And where there's quakes, there's often another disaster.
Just recently, we've seen a landslide occurring on Mars. It was captured with the cameras in orbit. So we know this does happen. And that can be hard to predict. We might put our base someplace which appears perfectly safe, and then a few years later realize that there's a landslide hazard.
Scientists are still unsure what started the 2008 landslide near the North Pole of Mars. It was in an icy area, and researchers believe most of the slide material was ice. That's just the type of place a colony might be located to take advantage of converting the ice to drinkable water. Even a distant quake could still trigger a slide near a colony. But what if a hidden fault line is running right under the buildings? In the future, space colonists living on the Moon or Mars will have plenty of